All right, 2-4, we got to do number 1. 1 says, sketch the graph of y equals the square root of x. Well, we can't take the square root of negative, so there's no graph over here. If we put in 1, square root of 1 is 1. If we put in 0, we get square root of 0 is 0. If we put in 2, that's not a pretty number. 3 is not, but square root of 4 is 2. So it goes up 1 over 1, up another 1 over 4, out to 4, or over 2 out 4, and then you can tell we're getting this sideways parabola. And that's what we wanted to graph. And that's one of our parent functions. Next question was 6. 6 says, true or false, the cube function is odd and is increasing on the interval negative infinity to infinity. The cubed, y equals x cubed. If you put a negative in for x, you get the negative of the whole thing. It is odd, yes. Is odd, and you can tell by the graph because if you rotate it 180, it lands on itself. Now to graph x cubed, we put 1 in, 1 cubed is 1. If you put 2 in, 2 cubed is 8. 6, 7, 8 up here. And if you put in minus 1, you get minus 1. If you put in minus 2, you get the opposite of that, minus 8. And you get this function. It goes up like this and like this. And it is always going up. It's steeper here than it is here, and it gets pretty slight, slackens there, gets less steep in here, but then it gets steeper again after that. So it is always increasing. From negative infinity to infinity, this function is increasing. Yes, it is increasing over the interval from negative infinity to positive infinity. This goes from negative infinity to positive infinity. That was 6. Now we'll do 7. 7 says, true or false, the cube root function is odd and is decreasing on the interval from negative infinity to infinity. Well, the cube root of 0 is 0, the cube root of 1 is 1, the cube root of 8 is 2, and the cube root of negative 1 is negative 1, because negative 1 times negative 1 times negative 1 is negative 1, and the cube root of negative 8 is negative 8, and it looks just like the last one, only sideways. And yes, it's odd because you spin it 180 and it lands on itself, or you can put a negative in here and the negative comes out and makes the negative of the function. So f of negative x is the cube root of negative x, which is the cube root of negative 1 times the cube root of x, and the cube root of negative 1 is negative 1. So we get, making the x negative changes the sign of the whole function. That's the definition of odd. That matches the definition of odd. It rotates on itself. It has point symmetry with the origin, in other words. 180-degree rotation, lands on itself, so it is odd. And then the other part that they said on number 7 was it's decreasing from negative infinity to infinity. And that is incorrect. It is increasing all the time. Not decreasing, increasing. From negative infinity to infinity. Okay? The next one is 8, I believe. Let's take a look at my notes here. Yes, 8 says true or false. The domain and range of the reciprocal function are the set of all real numbers. The reciprocal function. Well, the domain is not all real numbers because you cannot use 0 for x. The domain is all reals except 0. And there's no number you can put in for x and divide it into 1 and get 0. You can try dividing by 0, but that's undefined. So the range is not all reals. It's all reals except 0. You can't get 0 out of it. That's what they wanted you to understand about 8. And now we do number 14. And on 14, we're supposed to identify the function that looks like this. Well, the function that looks like that is y equals the absolute value of x. Let's see how that works. The absolute value of 1 is 1. The absolute value of 2 is 2. The absolute value of 3 is 3. And so it's steadily going up. If we put in -1, the absolute value of -1 is +1. The absolute value of -2 is +2. The absolute value of -3 is +3. And so this goes off at a 45 this way and a 45 this way, and so that's why it's a right angle in between it. And that's the absolute value function. And you are supposed to identify which graph is which, and that's the parent function for 14. Okay, and let's see. 18 is also in this, and it says what one looks like this. Whoop, whoop. Well, we just talked about that in number 7. It's the cube root of x function, which is cube root function is h, so the answer to this one is h. The absolute value function is g, so 14, the answer is g. So that's the correct answers for those two. And number 14. Okay. That's 14 and 18. Now I'll do another video. No, I'll just keep going here. Next one is 31. 31, it says find the domain of each function. Based on the graph, find its range. So we got a piecewise divine function. Y equals 2x sometimes, and y equals 1. It equals 2x if x is not 0, and 1 if x equals 0. So let's just graph this quickly. 2x, that's a slope of 2 with a y-intercept of 0. So that's a line that looks something like this. At 1 it's up 2. At -1 it's down 2. However, this is not used at 0, so there's a hole right there at 0, 0, 0. And it says when x is 0, use 1. So there's a dot, that's the only place. So this is a function, it passes the vertical line test. There's a value for all the x's, so the domain is from -infinity to infinity, or all reals. The range, well, this goes from -infinity to +infinity, except it doesn't have a y value of 0. So this is all reals except 0. There's no y value 0. It skips that and puts in 1 at that place and then goes back to drawing the line. It has everything else but 0. So that's 31. Next one was 35. And 35 says, look at this. F of x equals x plus 3 some of the time, it's 5 some of the time, it's minus x plus 2 some of the time. It says it's this one negative 2 is less than or equal to x, which is less than 1. It's 5 when x equals 1. And it's minus x plus 2 when x is greater than 1. So I'm going to draw this so you see how to do it. X plus 3. Y equals x plus 3. Slope of 1 going through 3. 1, 2, 3. Slope of 1. Down 1, 1. Down 1. Going this way. Down 1. Down 1. So this is at negative 3. And this is at 3. Negative 3. But I only draw this from x equal to negative 2. So that's really right there. Until x gets up to 1 and not including, so I draw just this piece, not there. Then I draw, that's 4, and then at 5 at x equal 1, so I put a dot at 5. And then I go to x minus x plus 2. 2 and minus x is down 1 for 1. Going like this. But I draw that line for x greater than 1. So right here is when it's equal to 1. And then for x's out here, I continue that line. So I have something that looks like that. A piece of a positive sloping line, but a hole there and a dot there. And a hole on this end going down. Now it asks me to give... Oh. Shoot, on 31, I only answered find the domain of function, locate any intercepts. The only intercept is a y-intercept, and that's 0, 2, 0, 1. It says C, graph the function, I did that. D, based on the graph, find the range, we did that. If it's continuous on the domain. Continuous means it's connected. There's a hole and it jumps, so not continuous. Okay, now let's do this one. Okay, first of all, we're supposed to answer what's the domain. Well, this function, it has values for x, can use values of x from minus 2 up to 1, not including 1, but then including 1. And then greater than 1. So it's got values all the way from negative 2 to infinity. So the domain is all reals where x is greater than or equal to negative 2. Okay, or you could do it in interval notation from negative 2, including negative 2, to positive infinity. We've got x's for all those. That's 1. Locate any intercepts. That's 0, 3. That's a y-intercept is 0, 3. X-intercept is 2, 0. Graph the function. Done. Based on the graph, find the range. So the range is going to be a little bit difficult. So it's going to go from the y heights starts at negative infinity, because this goes on down, down and down and down. So it has y values all the way up to 3. So it goes from negative infinity up to, but not including, actually goes up to 4. Up to 4, but not including the 4. And then it goes on, or it has one spot. It has a y value of 5. And so it goes from 5 to 5. In other words, only at 5. Okay? And was that it? Yeah. That was the range. Is the f a continuous on its domain? Is it all connected? Well, this is not connected and this is not connected, so it's not continuous. Okay. And then 44. 44. It's got a graph, and you're supposed to write a definition for each of these. And then write this piecewise function. So the graph has this. And then it has okay, so this is a line that has a slope of down 1 for 1, negative 1. So the function would be a line that's got a negative 1 slope, so it's negative x plus, and it goes to the origin, plus 0, or just negative x. Y equal negative x is this line. And we do that if x is on the interval from negative infinity to 0. Or we could say x is less than or equal to, including 0. Okay, so you could use that here instead of that. And then from 0 to 2, from 0, not including it, up to 2, including, because it's got a solid dot, we have this line, which also has a negative 1 slope, so it's negative x, plus it has a y-intercept of plus 2. The reason we get a hole there is because it's not including the x value 0, which has a, if you put 0 in there, you would get 2, but you don't get it because you can't put in 0. It says not including. You do get this one because you can't put in 2. And that's 44.